Hello friends, welcome back to our channel Laha Zindagi Edu-Care. Our channel provides online learning materials of maths and science from class 8 to class 12. Please visit our playlist section to enjoy free online learning materials. Okay friends, coming back to our topic of discussion function, this is the third lecture of functions. So till now we have discussed what is a function as a kind of relation, function as a correspondence. Then we have discussed domain, codomain and range of the functions. We have also discussed about equal functions. Then we have discussed what is a real valued function and how to find domain and range of a real valued function. Okay friends. So those who have not seen previous lecture of this topic, please follow the link given in description box or you may find these lectures in the playlist section. Okay friends. So today we are going to discuss some standard real functions like we will discuss constant function, identity function, modulus function, greatest integer function. Then we will discuss fractional part function, exponential function and logarithmic function. Okay friends. So we will start with some standard functions. So our today discussion topic is some standard real functions. Functions. Okay. Some standard real function. Under this topic, the first function we are going to discuss is constant function. Constant function. So what is a constant function? See, if k is any fixed real number, then a function given by fx equal to k for all x which is an element of real number say is called a constant function. So we can write if k is a fixed real number, then a function fx given by fx equal to k for all x is an element of real number set is called a constant function. Okay. So if we try to represent this constant function on a graph, how we can represent? So in this, the function fx will have a constant value k. So based on the value of k, it will be parallel to x axis. Okay. So y equal to k. So if we try to represent this on a graph paper, so if it is xy axis, this is x dash, y and y dash. Okay. So fx equal to k. If our this is our given function fx equal to k. So this much is k. value of y. So this straight line represents fx equal to k. So it is above or below the x-axis. If k is positive, it will lie above the x-axis, and if k is negative, it will lie below the x-axis. Okay, friends. So next function we will discuss is identity function. So let me clear this. Second one is identity function. So what is the identity function? See, the function which associates each real number to itself is called identity function. So we may write the function which associates each real number to itself is called the identity function. Okay. It is represented by I, or it is denoted by capital I. Okay, friends. So the function, we can represent this function as I from R to R. Okay. Or we can write I of x, I of x equal to x for all x is an element of R. Okay. So this function is identity function. The graph of identity function is a straight line passing through the origin and is inclined at an angle 45 degrees. So if we plot the graph of identity function, this is y-axis, okay? Y dash, and we can draw x-axis here, x and x dash. So our identity function graph will be this one. This will pass from here. It is passing from origin and is inclined at 45 degree with x-axis. So this graph fx equal to x or ix equal to x. Okay. If we see domain and range of the identity function will be equal to r for both domain and range. So domain equal to r and range is also r. Okay, friends. So next function we will discuss is modulus function. Let me print this. Now the third function is modulus function. So what is a modulus function? Function fx defined by the function fx given by fx equal to mod of x it is always positive. So it will be x when x is greater than or equal to 0, and minus x when x is less than 0. It will always be positive. So the function defined by f(x) equal to mod x is called modulus function. Okay. It is also called as absolute value function. This is function. Absolute value function. Okay. So this function is also called absolute value function. If we observe the function f(x) equal to mod x, domain will be real set R and range will be all positive real numbers including 0. Okay friends. So if we represent this on graph, it will be like this. See, mod x equal to x when x is greater than or equal to 0. So it will be at 45 degree, and mod x equal to minus x minus of x when x is less than 0. So this is y equal to x and this is y equal to minus x. So y will always be positive. This is our y axis and this is our origin. Okay. So this is a graph. If we write domain, so domain will be R and range equal to R plus. Okay. R plus and 0 is also included. We can write equal to x, which is an element of R, such that x is greater than or equal to 0. Okay. 0 comma R plus we can write here. So we will discuss some of the properties of modulus function. So what are the different properties? First one, as it will always be positive, so we can write for any real number x, for any real number x, under root x square equal to mod of x. Okay. So if x equal to under x equal to sine x, so under root sine square x equal to mod of sine x, or we can write sine x when sine x is greater than 0, or minus sine x when sine x is less than 0. So second property we can write, if a and b are positive real numbers, then first one is, or a, we will write a, x square is less than equal to a square It implies x or mod x is less than equal to a, and from this we will get x is greater than equal to minus a, or x is less than equal to a. That is, x will lie between minus a to plus a. Write clearly, minus a, this is x is greater than equal to minus a. Second b, when x square is greater than a square, greater than or equal to a square, it implies mod of x is greater than equal to a. From this we can conclude either x is less than equal to minus a, or x is greater than equal to a. Third one, x square is less than a square, so it is like a only, where equality does not hold. Okay, so mod x is less than a, or we can write x is greater than minus a and less than a. Next one, x square is greater than a square. From this we can get mod x is greater than a, and from this we can conclude x is either less than minus a, or x is greater than a. Next one, e, is x square is greater than a square and less than b square. From this we can conclude mod of x is greater than equal to a and less than equal to b. And from this we can write x is an element of greater than a but less than b. Okay, so minus b to minus a union a to b. So next property, f x square is x square is greater than a square and less than b square. Okay, it is like the above one, just where equality does not hold. So from this we can write mod of x is greater than a and less than b, and from this we can conclude x is an element of minus b to minus a union a to b. Okay friends, how we can represent this on number line? This is your a, this is b. So x is a to b. So this part, okay. Or if this is your minus a and this is your minus b, so it will lie also from either here to here. So this portion where x is not equal to a minus a or b minus b. So it will not be a solid circle. Okay. So in the properties of modulus function, one more property, just I will erase this. Okay. So third one is for real numbers x and y. For x, y, which is an element of R, mod of x plus y equal to mod of x plus mod of y, and this is equal, this will be when x is greater than equal to 0 and y is greater than equal to 0, or x is less than 0 and y is less than 0. So both will be of same sign, then only this property will hold. Next one is mod of x minus y equal to mod of x minus mod of y. This property will hold when x is greater than equal to 0, y is greater than equal to 0, and mod of x is greater than equal to mod of y. Okay? Or when x is less than equal to 0, y is less than equal to 0, and mod of x is greater than equal to mod of y. Okay? Next one is C. Mod of x plus minus y will be less than equal to mod x plus mod y. And next one is mod of x plus minus y is greater than equal to mod of mod x minus mod y. Okay, so this is all about modulus function. Next function we will discuss is greatest integer function. So let me clean this. So this is fourth one, fourth special type function, greatest integer function. This is also called as floor function. Floor function. Okay. So what is the greatest integer function? See, for any real number x, we use the symbol of greatest integer function. So it denotes the greatest integer less than or equal to x. So we can write for any real number x, we use symbol. Okay, this is a symbol of greatest integer function, or even we use like this. Okay, this denotes the greatest integer function to denote greatest integer less than or equal to x, less than or equal to x. Okay, so as it is less than or equal to x and is the greatest integer. So if for example we consider 3.75, so what is the greatest integer but less than 3.75 or equal to 3.75? So clearly we may see it will be 3 only. 3 is the greatest integer, and if we have 4, as it is integer, so its value will be 4 only. Next, if it is a fraction like 0.75, so if it is a positive fraction, so greatest integer less than or equal to 0.75 will be 0. Next, if it is a negative number like 7.5, so the integer less than or equal to this number will be equal to -8. Okay, friends. So if we represent this on a graph, So this is your graph. It is x-axis, x-axis dash y, y dash, and this is your origin. So this function will be indicated by if we represent all integers like this one is 1, 2, 3, -1, -2, -3, and this side we will indicate -1, -2, and -3, 1, 2, and 3. Okay, so the greatest integers less than or equal to 1. If 1 is not included, the number is less than 1, it will be equal to 0. If the number is less than or equal to less than 2 but greater than 1 or equal to 1, it will be 1. So 1 is included here. Similarly, if it is greater than equal to 2 but less than 3, it will be represented like this. Its value will be 2. Next, if it is greater than 3 and less than 4, it will be like this. Similarly, for negative, if it is less than 0 but greater than -1 or equal to -1, we like this one. Here it will be hollow circle. Similarly here, okay, hollow circle at -2. Then here this one. Okay. So this is a representation of greatest integer function. So what will be the domain and range of this function? So clearly, if we see the graph, domain is the set of all real numbers. So domain equal to R. And what is the range of this function? Range will be all integers. Okay. So we can write Z, all integers. Okay. Now we will discuss some important properties of greatest integer function. So what are the different properties? Property A is if n is an integer and x is a real number between n and n plus 1. So first we write the consideration. If n is an integer, is an element of Z, and x is a real number, x is an element of R, such that x is a real number between n and n plus 1, such that x is greater than n and less than n plus 1. Okay, so different properties will be as below. Minus n will be equal to minus n. Okay, next one be x plus k. It will be equal to x greatest integer function of x plus k if k is an element of z or k is an integer, so it will be x plus k. Next property 3, minus of x equal to minus x minus 1. Okay. Next one is x plus minus x, greatest integer function of x plus greatest integer function of minus x will be 0 if x is an integer and minus 1 if x is not an integer. Okay. Then next property is x minus greatest integer function of minus x. So greatest integer function of x minus greatest integer function of minus x will be equal to 2x if x is an element of z and 2x plus 1 if x is not an element of z. Okay. Next property is x is greater than equal to some integer k implies x is greater than equal to k, where k is an element of integer. Okay. So next property, let me erase some portion. Okay. So next property is x greatest integer function of x is less than equal to k. It implies x is less than k plus 1. Okay. Where k is an integer. Next one, x greatest integer function of x is greater than k. It implies x is greater than k plus 1, where x is an or k is an element of integer. Next property is greatest integer function of x is less than k. It implies x is less than k, where k is an element of integer. Okay. Next one is greatest integer function of x plus y equal to greatest integer function of x plus greatest integer function of y plus x minus greatest integer function of x. Okay. For all real number x and y, or x y is an element of R. Next one is greatest integer function of x plus greatest integer function of x plus 1 by n plus greatest integer function of x plus 2 by n up to x plus n minus 1 by n. So it will be equal to nx, greatest integer function of nx, as all 1 by n, 2 by n, 3 by n, it will not contribute in greatest integer function. Okay. So n is an element of natural number. So next we will discuss smallest integer function. Okay, let me clean this. It is also called as ceiling function. Okay, friends. So, what is the smallest integer function? As we have discussed, greatest integer function. So, in case of the smallest integer function for any number x, which is an element of a real number, we use the symbol. So, we use normally this symbol. Okay, for smallest integer function. So it will be greater than or equal to x. So we can write for any real number x, we use the symbol. Okay, to denote the smallest integer greater than or equal to x. Okay, so if for example we consider some number 5.7. Okay, so what is the smallest integer function of 5.7? It will be smallest integer greater than or equal to x. So greater than or equal to x will be just greater than 5.7, that is 6. Next, if we consider a negative number like minus 6.5, so the greatest integer or integer greater than minus 6.5 will be minus 6. Similarly, if it is an integer, the value of smallest integer will be integer only. If it is a fraction like 0.6, okay, so we have to see integer greater than zero point 0.6, which will be equal to 1. So like this we can define. So how we represent the smallest integer function on a graph? If it is our y-axis and this is our x-axis. Okay, so this is 1, 2, 3, minus 1, minus 2, minus 3. This side 1, 2, 3, and this side minus 1, minus 2, minus 3. Okay, so for 1 or less than 1 but greater than 0, it will be 1. So y will not be equal to 1 for x is y will not be 0, or we can say y equal to 1 for x greater than 0 but less than or equal to 1. Similarly here, and it will be here. Okay, next one, greater than minus 1 it will be 0, then greater than minus 2 it will be minus 1. Okay friend, so this is the representation of the smallest integer function on a graph. So what is the domain and range in this case? So here also domain will be all real numbers and range is set of all integers. So range is equal to z. Next we will discuss properties of the smallest integer function. So what are the different properties of a smallest integer function? First one, if we see minus n. So n is an integer. So it will be minus of smallest integer function and n is an element of integer. Second one, minus of x equal to minus of x plus 1. X is an element of real number minus integers. So x is a real number but not an integer. Third property is x plus n, the smallest integer function of x plus n. This equal to smallest integer function of x plus n. Okay, where x is an element of r minus z and n is an element of z. Next property is the smallest integer function of x plus smallest integer function of minus x. It will be 1 if x is not an integer and my 0 if x is an integer. Okay. Next one is fifth property. Greatest integer, smallest integer function of x minus smallest integer function of minus x. This will be equal to twice of smallest integer function of x minus 1 if x is not an integer and twice smallest integer function of x if x is an integer. Okay friends. So next special type of function is fractional part function. So let me clean this. Fractional part function. So what is a fractional part function? So if x is any real number, then we denote this. See, it is denoted by x. Okay, like this. We use this symbol to denote the fractional part or decimal part of x. Okay, friends. So we can write for any real number x. We use the symbol this one. Okay, to denote the fractional part or decimal part of x. Fraction or decimal part of x. Okay, so if we consider some fractional number, like if we consider 4.45. Okay, so just a minute, this is not the symbol, we have to use this symbol. Okay, 4.45. So we have to see what is the decimal or fractional part in the given number. So it will be only 0.45. If it is a negative number like minus 2.75, so it can be written as 3 minus 3 plus 0.25. Okay, so it will be 0.25. Next, if it is an integer like it is 5, so its fractional part will be 0. It is a negative integer minus 4, then its fractional part will also be 0. So in this case, if we see what is the domain and range. So domain is the set of real number R, and range will be from 0 to 1. It can be equal to 0 but less than 1. Okay, and if we see by definition, it denotes only the fractional or decimal part of x. So we can write x equal to greatest integer function of x plus fractional part of x. Okay, if we take for example, if we have, so this is an important property, this one, for all, this is applicable for all x is an element of real numbers. Okay, if we consider any number like suppose 3.75, so this can be written as greatest integer function of 3.75 plus fractional part of 3.75. What if we check, it will, the greatest integer function of 3.75 will be 3 and fractional part will be 0.75. So which is nothing but 3.75. So x can be written as greatest integer function of x plus fractional part function of x. If we represent this on a graph, we can represent like this: x dash x y. Okay, so it will be, if this is 1, 2, 3, minus 1, minus 2, and minus 3. So if x lies from 0 to 1 but less than 1, it will be indicated as this. So for all integers it will be 0. Okay, and this is 0, 1. Okay, it will be like this one. So this is the graphical representation of fractional part of x. Then next we will see sinum function. So let me clean this. Okay, so what is a sinum function? So we can write this: the function f defined by fx equal to mod of x by x when x is not equal to 0 or 0 when x equal to 0, or it can be written as fx equal to 1 when x is greater than 0, 0 when x equal to 0, or minus 1 when x is less than 0. So this given function is called sinum function. Okay. So what is the domain and range of this function? So domain will be all real numbers. Domain is the real number set, and range is minus 1, 0, and 1. Only these three elements. Okay. If we represent sinum function graphically, we will get for x greater than 0, it will be 1. For x equal to 0, it will be 0. And this is 0, 1. And for x less than 0, it will be minus 1. So 0, minus 1. Okay, friends. So this is the representation of trinum function. Okay. So today we have discussed the special types of functions under which we have covered constant function, identity function, modulus function, greatest integer function, smallest integer function, and fractional part function. Also we have covered sinum function. I hope all of you have understood today's lecture. If you have any doubt or any query regarding this topic, please let me know in the comment box. I will try to resolve your doubts. Okay, friends? And if you have seen the whole video and liked it, please like the video and subscribe our channel Ahadinti Educare if you have not subscribed till now. Also press the bell icon button so that you will get notification when next video will be uploaded. Okay, friends? Thank you.